All right, so 6, you're going to take that 125 and break it down. Again, you could do this a couple different ways, but it would be 5. Actually, this one, no. This would be 5 and 25, which would be 5 and 5. There are 3 5s there. One pair is going to come to the outside, and then one's going to get left underneath. So you'd get the 10 times the 5, which is 50 square root 5. Raise your hand if you got it right. Okay, good. All right, 7... 600. So I'm going to break this down. Again, you could do this a lot of different ways, but let's say I did 6 and 100. I can do 2 and 3, and then 100 could be 2 and 50, 2 and 25, 5 and 5. So I've got one pair of 2s, it's going to come to the outside, and I've got one pair of 5s, it's going to come to the outside. Left underneath is a 3 and a 2. So on the outside, 5 times 2 is 10, times 5 is 50. And underneath is 3 times 2, which is 6. Yeah.
It's not really off of this question, but like, you know how you said when the 2's on the outside, the little square root, and if it's at addition, probably have to FOIL it? Does that only go for the radicals? Like if it was,
No.
It goes for all of them?
Any binomial. So anything with 2 terms on the inside, adding or subtracting between them, and the parentheses with the squared.
Yeah.
Yep.
Okay, so you have to FOIL. Okay.
So if it was like x plus 2 in parentheses squared, that's x plus 2 times x plus 2. Yep. All right, the next one I had you skip was 16. What can you do with this one? How?
6 goes into 90, 15 times, and then 6, 1.
Good. So this becomes 1 because that whole square root 6 is going to cancel out, right? It's going to be square root 1, which is 1, right? We don't need it. So the top is 15. The bottom would be square root 15. Can it stay that way? No. So what do we do?
Multiply it by the square root.
Good. You're going to multiply both the top and the bottom by the square root 15. We're rationalizing this. So on the top, it's 15 square root 15. And then the bottom, root 15 times root 15 is what? 15. Is that in simplest form? Nope. What can I do? Cancel out the 15s that are outside the radical. So my answer is simply square root 15. Questions on that one? Yeah.
You can only cancel out the 15 if there's 2.
Correct. All right, 20 was the one we waited for next. This time I've got a difference, right? But they're both square roots, so I'm going to try to break them down first. 32 can get broken down into 2 and 16, which is 2 and 8, which is 2 and 4, which is 2 and 2. So a pair of 2's comes to the outside. Another pair of 2's comes to the outside. There's a single 2 left underneath. I'm going to multiply what I took on the outside by what's already there. So 3 times 2 is 6, times 2 is 12, and then square root 2. Minus, I'm going to repeat that process with the 63. 63 would be 3 and 21. 21 is 3 and 7. I have a pair of 3's, so the 3 is going to come to the outside with that minus 4, and I get negative 12 square root 7. Now the 12's are the same, but that's not what I need to be the same. What I need to be the same is the square root. So because I have square root 2 and square root 7, these cannot be combined. They would stay exactly as they are. Okay, and I also had you skip 22 on this slide. So we talked about that squared means I have to expand this. So it would be 3 square root 7 minus root 3. And then I have to FOIL it. You cannot distribute the exponent when it's a sum or difference inside. So now I'm going to do first times first. Now even the first thing has 2 parts. You've got 3 times 3, which is 9. And then square root 7 times square root 7, which is what? Just 7. Good. Then I go 3 square root 7 minus times the negative root 3, which would be negative 3 square root 21. Then I go inner negative root 3 times 3 root 7, which is minus 3 square root 21. And then last, negative root 3 times negative root 3, which becomes a positive 3. Any root times itself, you ignore the root. With me so far? So this is 63. These two can get combined. They have the same root. So this would be minus 6 square root 21 plus the 3 at the end. And then 63 plus 3 would be 66 minus 6 square root 21. Now, just to be sure, you would break down that 21, but it's 3 and 7, and that does not simplify. There's no repeated factors. So 66 minus 6 root 21 is the answer. Questions on that one? All right, so with 23, there's 2 underneath the square root, but they don't simplify, so I have to get rid of what's in the bottom. I'm going to rationalize by multiplying both the top and the bottom by square root 3. I get 7 root 2 times root 3 would be root 6 over root 3 times root 3 is 3. And I can keep it just like that.
Oh, you can't simplify it?
In what way? You can't put the 3 into the 6 because one's under a root and one's not. Is that what you meant? Yeah, only if they're both under the root or they're both outside the root can you simplify them. 24, again, the square root in the top is fine. The square root in the bottom is what's the problem. So I'm going to multiply both the top and the bottom by square root 3. In the numerator, I would do 4 times root 3, which is 4 root 3, plus root 2 times root 3, which is root 6, over square root 3 times square root 3, which is 3. And again, can't simplify because that 3 is on the bottom is not under the root. $25. Now I've got a sum in the bottom, so we're going to multiply by the opposite, 3 minus square root 2. So my numerator, 1 times 3 minus root 2 is just 3 minus root 2. The denominator, I could FOIL out. I'd get 9 minus 3 root 2 plus 3 root 2 minus 2. These would cancel, and I'd get 7. Or I can do the shortcut, which is square the first one minus square the second one. 9 minus 2, which is 7. So again, the shortcut only works when you're multiplying by an opposite, right? So because we do the conjugate is the opposite, that's the only time we can use that shortcut. Any other time, we're going to FOIL it out. Joey?
Why wouldn't we just multiply each one by -2 square rooted? Because isn't that the only one that can be in the denominator?
Right, but try it out. Look what happens, right? 1 over 3 plus root 2. If I were to just multiply by even just a root 2, if it was a negative is what you're saying, the top, obviously I get negative root 2. The bottom, I'd get 3 times negative root 2, and I end up with negative 3 root 2, and then root 2 times negative root 2, which is negative 2. I still have a root in the bottom. So if it's a sum or difference, you have to multiply by the opposite of the whole thing. So duplicate the expression, but put the opposite sign in between if there's a sum or difference in the bottom.
You only put that in front of it, you only change the sign in front of it.
That's right, which would be, or whichever's in between, because even if it was the reverse, like if it was root 2 plus 3, you would do root 2 minus 3, it still cancels it out. As long as you change the sign.
And then you go back to 24.
Mm-hmm. All right, we're going to go. This is P2B. You told me which ones you wanted me to do, right, already? Did we do this? Hang on. Oh, it's not that one. We were asked yesterday. So this is P2B's homework. For number 4, you've got 2 parts to kind of look at separately. The coefficient part, which is the 6 and the 4. 2 goes into both of those, so 2 goes into 4 twice and into 6 3 times. That's how we'd simplify those, just like a regular fraction. But then the other ones, the r's have negative exponents. So the r to the negative 6 is going to come to the top as r to the 6th. And the r to the negative 3 is going to go to the bottom as r to the third. And now you've got r's in the top and in the bottom. I'm going to subtract the exponents and keep it where it's larger. So 6 minus 3 gives me 2r to the third in the top and 3 in the bottom. You could write it as 2r to the third over 3, or like this, Miss Ferrier has it separated out like that. Either way, it doesn't matter, it's the same thing. As long as r's not in the denominator, it's in the right spot. Okay, number 9. 3pq times q squared over 6p squared q to the fourth. So the first thing I'm going to do is combine by multiplying in the top. I'd get 3p to the first, q to the first times q to the second is q to the third over 6p squared q to the fourth. The coefficients would simplify. 3 goes into 6 2 times. You've got 1p in the top and 2 in the bottom, so there's only 1 left in the bottom. And you've got 3 q's in the top, 4 in the bottom, so there's only 1 left in the bottom. So my numerator got completely canceled out. Only thing left there is a 1. The denominator is 2pq. Okay, 10. First thing I'm going to do is distribute the exponents. Okay, so the first thing you're going to do is multiply out the exponents, right? So this becomes 4a to the fifth. This a is going to get multiplied, that 3 is going to get multiplied by the negative 1, so it's a to the negative third over 2a to the negative second times the negative second makes this a to the fourth. Then I would move whatever's negative instead of trying to add and subtract. I would just get rid of the negatives with the movement. So I'm going to move the a to the third to the bottom. So 4a to the fifth over the a to the fourth that's already there. And now I bring the a to the third to the bottom. Now I can add the ones in the bottom, a to the fifth over, this would be a to the seventh. And then I can say a to the fifth, subtract from here, leave it where it's larger, which would be in the denominator.
What was the answer for number 9?
Next one, 17 is negative 8 to the 3/4, right? So the negative is not in parentheses. That means the negative is going on the front. Then it's the fourth root of 81 raised to the third power because the bottom slides over, the top drops down. So now I'm going to take 81, 9 and 9, 3 and 3 and 3 and 3. There are 4 3's there. So the negative's still on the front, and then it's 3 to the third power. And 3 to the third is 27.
Oh, so the negatives in the front and no parentheses?
It's the last thing that gets applied.
Okay.
Yep. Like if you're looking at that question on your test, on your quiz or whatever, I might go as far as to going over to my answer and putting the negative there before you even do the math.
Because I said, if I put the negative in there, and I was like, well, there's no solution.
Right. It can't be in, yeah. So if it's in the parentheses, there would be no solution. And then what was the other one? 20. This one, so 23. I would start by distributing the 1/4 to each of them. 16 to the 1/4. M to the 3 times 1/4 would be 3/4 over n to the 1/4. So they all got the exponent on the outside. Times, I'm going to do the same thing here. 9 to the 1/2. N to the negative 1/2 over m 2 times 1/2 is just 1. With the constants, you can actually work these out. The fourth root of 16 is what that means, and that's 2. M to the 3/4. The 9 to the 1/2 is the square root of 9, so this would go over n to the 1/4. 9 to the 1/2 is 3 because it's square root of 9. I'm going to move the n to the 1/2 to the bottom. And I'm going to leave that m that's already there. Now I can multiply straight across in my numerator. So 2 times 3 is 6. M to the 3/4. Yep.
How did you get to 16 to 2 again?
So the fourth root of 16 would be 2 and 8 and 2 and 4 and 2 and 2. There's 4 2's. So it's just 2. Yeah. Okay, so I did the numerators. Now the denominators, n to the 1/4 times n to the 1/2 means I'm going to add that 1/4 plus 1/2. I have to give it a like denominator, so times 2 times 2. This is 2/4 plus 1/4, which is 3/4. So this goes n to the 3/4. And then m to the 1st. The last thing you have to do is there's an m in the top and an m in the bottom. 1 is bigger than 3/4. So I would do 1 minus 3/4. Keep it where it's larger, which is in the denominator. So n to the 3/4, and 1 minus 3/4 is 1/4. So you could keep it like that. You could have also put it in radical form, but I would say leave it like that. It's one less step you have to do. There are going to be questions on your quiz that are easy, like the ones we did at the beginning of today's lesson, where you're just simplifying square roots. And then there's going to be a couple that are terrible like that, okay? So they're not all like that, and they're not all easy. There's a little bit of in between, okay? Just take it step by step. The worst thing you can do is leave it blank. And you'll learn, like if I could teach you anything this year, is that if you get to a question you don't know how to do, skip it. Find something easy you're comfortable with. Build your confidence back up. Then go back to it later, okay? But don't let it rattle you. If the first question is what stumps you and you let it rattle you and you are mess up for the whole rest of the quiz, that's a horrible situation to be in. So if you get number 1 and you're like, that's hard, go to number 2. That's hard, go to number 3. You're bound to find something in there that you are good, and then go back to the ones that you need to do later. 22? Wait. All right, 22. The first thing I'm going to do is distribute the exponent in. So 2/3 times 2 is 4/3. I get x to the 4/3 over, distribute this in, 2 times 7/3 is 14/3. So x to the 14/3. Then what's bigger, 4/3 or 14/3? 14. So this is going to happen. Then I'm going to subtract, but then I'm going to leave it in the bottom where it's bigger. 14/3 minus 4/3 means this is gone. So 1 over x to the 10/3. And again, you can leave it like that. You don't need to rewrite it in radical form. All right, so 6 has a square root in the bottom, and it's a sum or difference, which means we have to multiply by the opposite. So I'm going to take my root 3 over square root 5 plus square root 3 and multiply both the top and the bottom. You can't simplify if it's not multiplication unless all of them had a root that would be simplified. So if I had square root 5 over square root 10 plus square root 15, the same thing goes into all 3 parts of those. That I can simplify. But I cannot simplify the 3 into the root 5 on the question I'm given, so you cannot. It would have to go into all 3 parts if there's a sum or difference involved. So I'm going to multiply this by square root 5 minus square root 3. My numerator gets distributed. Root 3 times root 5 is root 15. Root 3 times negative root 3 is negative 3. The denominator, who asked for this one? Sorry. Did you use a shortcut or did you FOIL it out?
I folded it out.
Okay, so square root 5 times square root 5 is 5. Square root 5 times negative square root 3 is minus root 15. Root 3 times root 5, root 3 times root 5 is plus root 15. And then root 3 times the negative root 3 is negative 3. So these cancel. 5 minus 3 gives you 2. You're welcome. All right, we're going to FOIL them out. So 4 root 5 times 3 root 5. I'm going to do 4 times 3, which is 12. And then square root 5 times square root 5, which is 5. Then I go outer. 4 root 5 times 2 is 8 root 5. You're going to multiply what's on the outside. Negative 1 times 3 root 5 is minus 3 root 5. And negative 1, God bless you, times 2 is negative 2. 12 times 5 becomes 60. 60 minus 2 is 58. And then these both have a radical 5 on them. So 8 minus 3 is positive 5 root 5. Yeah, well, we're not getting through this today. All right, root 2 minus 1. First, root 2 times root 2 is 2. Outer, negative root 2. Inner, negative root 2. Last, positive 1. 2 plus 1 is 3. Negative root 2 and negative root 2 is negative 2 root 2. Page 2. 7 is 2 root 30. 8 is 30 root 2. 9 is technically the absolute value of z because it can't be negative, but if you left that off, that's okay because we didn't talk about that. If you just have 10z, it's okay. But usually if it's an even root underneath on a variable, you have to do absolute value because that variable can't be negative. 10, 4b squared times the square root of 2. 11, 5r times the square root of 3r. 12, 30. 13, 6. 14, 7. Nope, 14, 9. Sorry. Questions on these? Yep. Sorry, Madison, go ahead.
Can you work out
10. Okay. Yeah.
Can you go back to the answer?
After this one, I'll go back, okay? So I'm going to break this apart separately. I can do just the 32. So 32 would be 2 and 16, 2 and 8, 2 and 4, 2 and 2. So I get 2 2s. One's going to come to the outside. Another 2 2s. Another one's going to the outside. The 2 by itself is going to stay underneath. So numerically, just the coefficients, I've got 4 on the outside and 2 on the inside. Now with the exponents, there would be 4 b's here. So I'd take 2 b's, one comes to the outside, take another 2 b's, a second comes to the outside, and that means I'd have b squared on the outside, nothing left underneath.
Okay, thank you.
You're welcome. Now the shortcut on that, like if you want to try it, is you take the index and divide it into the exponent. So because that square root is a 2, 2 goes into 4 twice, that's how many b's come to the outside. If you do that trick with like number 11, 2 goes into 3 once, so 1r is going to come to the outside, but then there's 1 left out, which means it stays underneath. No, you're not subtracting, you're dividing. In this case, yes. But if it was 5, let's say it's the square root of r to the 5th. That's not root 3. I mean, that's not r to the 3rd. That 2 goes into 5 twice, so r squared comes to the outside, and 1 is left underneath. If that like throws you, multiply out 5 r's, just like we do with the factors, and cancel them out. This would bring out 1, this would bring out 2, and there'd be 1 left underneath.
What if it was the cubed?
Then you just do the same thing. So if it's cube on the outside, r to the 5th, you can either write out 5 r's, cancel 3 to bring 1 out, there'd be 2 left underneath. Or you do 3 into 5, it goes once, so r comes to the outside, and there's a remainder of 2 that stays underneath.
And then you couldn't just take that R to the outside.
No, because, sorry, there should be an index. Because it's 3, you'd need 3 of something to bring it to the outside. Samuel, oh.
Can the b go on the right of the square root?
Sorry, say that again.
For number 10, can you go up? You put like 4b squared square root of 2. Can the b2 go on the
Be out here, as long as it's not underneath the root. So just be careful and don't extend your root to be over it. Valerie, which one did you want me to go back to?
Oh, I just wanted to look at, you were scrolling.
Oh, okay, sorry. We good on the rest of this page? Summer.
7.
Oh, hang on.
What does the answer say for number 9?
9 is 10 absolute value z, but I said if you just have z, it's okay. Technically, it's supposed to be absolute value because it's got to be positive, but we didn't talk about that yesterday, so it's okay. Valerie, you said 7?
What's, is that a C in number 9? Or a 7?
No, it's absolute value of z.
Why is it absolute value?
Because it technically has to be positive, but I also said if you don't have it, If you just have 10z, it's okay. That variable has to be positive, otherwise you wouldn't be able to square root it. That's what the idea behind it is. But if you just have 10z, it's okay. Yep.
Is that gonna be on the test?
The absolute value I would not expect you to have done. Okay, 19, you've got two parts. You've got the numeric part without the square root, and then you've got the part underneath the square root. So the numbers outside the square root get simplified because 2 goes into 14 7 times. The number underneath this square root gets simplified because 5 goes into 320 64 times. So my denominator is 0. I mean, not 0, it's 1, sorry, so it's gone. And the top is 7 square root 64. The square root of 64 is 8, so this is just 56. You're welcome. Hadley, which one?
Oh, I see. And then, I got 17 and 18.
Okay, 17, they're all underneath the square root. So you can multiply it so they'd all be under 1 square root. I'd get 3 times 8 over 4 times 9. I can even go a step further and say if it's a fraction, that means there's a square root in the top and a square root in the bottom if you want to separate them out. So in the top, I have 3 times 8. 8 is 2 times 4, which is 2 times 2. A pair of 2's goes to the outside, so the 2's on the outside of the numerator. 3 and 2 don't have a pair, so it goes underneath as 6. The denominator, 4 becomes 2 and 2, and 9 becomes 3 and 3. So I can bring out a 2 and I can bring out a 3. So my denominator is 6. And now I can go one step further because 2 goes into 6 and they're both outside the radical. And I'd get square root 6 over 3. $18, you said 2? So the 7 and the 35 that are both under the radical, I can simplify. 7 would go into 35 5 times. And I'd end up with 6 over square root 5. And then I'd rationalize root 5 over root 5, which is 6 root 5 over 5.
Oh, I forgot to do
Okay. Okay, 21. This is all multiplication. So even though there's a negative in there, that's not a sum or difference. This is all multiplication. So I would group together all the coefficients. I would group together 3, -2, and 3, and multiply those out. So this is -6 times 3, which is -18. And then I would group together all the radicals. So 2 times 8 times 27. 2 is already prime. 8 becomes 2 and 4, 2 and 2. 27 becomes 3 and 9, 3 and 3. So here's one pair of 2's from the 2 that I multiplied by and the 2 from the 8. One's going to come to the outside. A second pair of 2's, so another 2's coming to the outside. A pair of 3's, and then there's 1, 3 left underneath the radical. And then you multiply all this out, 4 times 3, which is 12. This is the example from the notes yesterday. And that's -216 square root 3. Madison.
And you could have just like multiplied everything under the radical and then
Sure, that's just a big old number you got to break back down. It's just wasting time. And if you multiply it out wrong, now everything after that's wrong. So I would keep them as separate factors, especially because you're not going to have a calculator. Yeah, make it as easy as possible on yourself. Don't do that. That's good. Just make all the mistakes you want in the homework. Just don't multiply wrong on the quiz or test, right? All right. 22. 12ab. 24, when you multiply square root of n times square root of m, it's the square root of m to the 4th. But then there's 4 m's. They cancel out in pairs, so there's only 2 m's when you bring it to the outside. And then it'd be plus 6 square root m, because you'd multiply those out. 25 is 20x. So when it's a minus, you can't combine them, right? So minus, you're going to split them up. simplify them separately, because they both simplified to have a radical 5, now you can combine them. If it was 5 root 80 times 12 root 5, now you would combine them underneath one radical. Okay, so watch for your plus and minus in between them, because that's the difference. If it's all multiplication, you can combine them all together. If it's addition or subtraction, you can't unless they're the same root. Xavier, you have a question?
Yeah, I have a question about, I just want.
Okay, 32 square root 13 minus 2 square root 5 squared means I have to duplicate this. So square root 13 minus 2 root 5, and then FOIL it. So root 13 times root 13 is 13. Root 13 times negative 2 root 5 is minus 2. Square root of 13 times square root of 5 is square root 65. Negative 2 root 5 times root 13 is negative 2. There's that square root 5 and square root 13 again, so this is square root 65. And last, negative 2 times negative 2 is going to give me a positive 4. Root 5 times root 5 is just 5. So I have 13. These are like terms because they both have the square root of 65. So this becomes minus 4 square root 65. And then 4 times 5 is 20. Now the like terms are 13 and 20. I get 33 minus 4 square root 65. And then I probably would have checked just to make sure this doesn't break down, but we know it's 5 and 13, and those are both prime and neither repeats. So I keep my answer as it is. $33 is your rationalizing. So 33 is 1 over 2 plus root 3. You'd have to multiply both the top and the bottom by the opposite of the bottom, 2 minus root 3. 1 times 2 minus root 3 is 2 minus root 3. Shortcut on the bottom is 2 squared minus square root 3 squared. 4 minus 3, which is just 1, and then the numerator is my answer.
Where do
Joey.
I find the equation?
Say again?
Can,
No, Hadley, say it. What?
Where do you find the equation?
There should be. Oh, I did not publish it yet. Quiz review. So this one, there again, you've got a square root in the denominator. You got to rationalize it. So I'm going to multiply both the numerator and the denominator by the opposite of the denominator. You will get something like this on your quiz where it has a binomial on the top and in the bottom. Okay, so you want to make sure you're comfortable with it. I'm going to multiply both the top and the bottom by it. So in the top, I've got to FOIL it out. Root 5 times root 3, which is root 15. Root 5 times negative 1 minus root 5. Negative 2 times root 3, negative 2 root 3. And negative 2 times negative 1, positive 2. That whole thing is my numerator. None of them are like terms, so it looks weird, but it's going to stay that way. The denominator, I'd get the square root of 3 squared minus 1 squared, which is 3 minus 1, or 2. And then 2 only goes in a part of them. Like, it can go in here and it can go in here, but you can't reduce it unless the 2 goes on all 4 of those terms, and it does not. So it stays like that. Yep.
why can't you just, multiply the square root of 3 times the square root of 5 for the,
For which part?
instead of foiling on the top?
Because it's a binomial, root 3 minus 1. It's not just root 3. If it's just a single term, you can do that. But if it's a binomial, if it's got 2 terms, which the bottom, it's going to have 2 terms tomorrow. 2 terms, you have to multiply by the opposite, which means it's 2 terms. And it's a 2 term times a 2 term, which means FOIL. All right, so your quiz review. The quiz review has like the answers are blank at the end. Okay, ignore those last couple pages. The quiz review goes through all of P2, so it's got A, it's got B, it's got C. Okay, this is a non-graded assignment because the answers are going to be published at 2:30 today. So your job tonight is to go back and check your work. Okay, obviously you don't have a ton of time to work on this right now. You have 5 minutes, but the homework while you're doing it, my recommendation is do the work first and then check your answers. I see a lot of people will open it Notability side by side with the solutions and be checking and you're kind of cheating yourself because you can see the answers before you get to the end, which is a false sense of security, right? There's obviously not going to be an answer sheet next to you on your quiz tomorrow. So do you want to check them? Yes, but after you complete them. Even if you go one at a time, that's fine, but you want to make sure you work all the way through this. So you do not need to turn this in. It is non-graded. There is no submission on it, okay? But there is this one, and the solutions will become available at 2:30. And then there's even an extra review should you want to push it a little bit further. Don't do it all if it makes you stay up till 3 a.m. Just do one, okay? But if you're already good, if you can move quickly through these, or you know which ones you struggled with on the original review, so on the extra review, you only go to those because you're confident in the other ones, then use it that way, okay? But all the solutions for the second one are already there, and the solutions for this one will be there beginning at 2:30 today. You'll be able to click on that and open up that document. Tomorrow when you come in, so I have you guys at the very end of class, right? But I mean at the very end of the day. But when you come in on a quiz day, there's a little bit of time for questions, and then we jump into the quiz. On a test day, there's no time for questions. So we usually have extra on the review side. Like you only have a half a day review kind of for a quiz, whereas you'll have a full day to 2 days review on a test. If you know you're struggling, I am here after school, after the Mu Alpha Theta meeting, so like 2:45, I'll probably be back in this room today, and I'm available tomorrow morning, okay? So I will be in my room by 7:20. If you know you've got questions, please ask for help, okay? The quiz is 10 questions. It is all open-ended, so there's no multiple choice, okay? And there's always partial credit, so the worst thing you can do is leave a question blank, because obviously I can't give you partial credit on it, okay? Not partial credit like I'm going to draw Mrs. Chrisweiser a picture and hope that she gives me, or say Jesus is the answer, because yes, Jesus is the answer to everything, but not on a math quiz, okay? But if you're at least getting part, like let's say you get the square root part right, but maybe the simplification of the other part's wrong, or part of, the sign's right, or not, maybe the sign's wrong on your answer. Those kinds of things you'll earn partial credit for. So you have to at least try it. Questions for me? Yeah.
How long do we have?
You'll probably have 30 minutes. We usually gauge it like based on the first class. Like we usually say, okay, about 30 minutes. And then if they need a little bit extra time, then we'll adjust throughout the day. There's 3 teachers that teach it, and we have a group chat. We're like constantly in communication. So I'll give it first in my J period. And so kind of based on how they do, we'll adjust through the rest of the day. Yeah.
And, did you have any questions?
10. Yep. And it's mixed. It's a little bit from A, a little bit from B, a little bit from C. Any other questions for me? Yeah.
Okay, so this